Now, dear children, we do the last topic of this chapter, nuclear structure, which is nuclear reactions. Okay. Now, the detailed explanation of nuclear reaction actually lead to the discovery of the other particles. Like we know that there are the particles like electron, proton, neutrons, which are the subatomic particle of the what? Atoms. Okay. Now, but there are other particles other than this subatomic particle. Okay. So the discovery of new particles can also be done. Okay, with the help of nuclear reaction. But what is actually nuclear reaction? So nuclear reaction is actually a strong interaction. It is actually a what? Let me just write upon. It is a strong interaction. Okay, interaction of an what? Atomic nucleus. Atomic nucleus. Okay, with an what? Elementary particle. With an what particle? Elementary particles. So when nucleus of any element have a strong interaction, okay, interaction takes place with the elementary particle, such type of reaction, strong interaction leads to the formation of new particles and new element, and the new nucleus is formed, and this type of reaction which is occur is called a nuclear reaction. But in case of nuclear reaction, some energy may also liberate. Okay, so that's why it is a what? Strong interaction of atomic nucleus with the what? Elementary particle, resulting in the formation of new nucleus. See, after the reaction, what will form? Formation of what nucleus? New nucleus. Formation of new nucleus. And one or more new particles. Not only a new nucleus is formed, along with what? The formation of one or more new particles will form. New particles is formed. Okay, so nuclear reaction is a strong interaction, as I said already, with the atomic nucleus with the elementary particle. When the reaction takes place, we get a new nucleus along with the formation of new particles. But it can be more than one new particles will form. Such type of reaction which occur is called nuclear reaction. Okay. Now, in order to express a nuclear reaction, it is expressed by a general relation. So there is a general equation that can be written for nuclear reaction. So I am writing general equation. So general equation of nuclear reaction, and it is written as X. So I am writing with the symbol first. X, say, plus small letter a equivalent to y plus capital letter Y plus small letter b. So general equation of nuclear reaction can be represented this way also. So in this relation, if you see, I am writing with the symbol X, capital letter X. Now this capital letter X is the initial nucleus. This is called what nucleus? Initial nucleus. The nucleus which are going to have strong interaction with the particles. Okay, and this A is called what particle? Initial particle. Initial also called original particle. The particle which is going to have interaction with the nucleus. So once a nucleus interact with the initial particle, then there is a formation of new nucleus, and this nucleus is called Y, and we can mark this Y as what nucleus? Final nucleus. We call this as what? Final nucleus. Along with the final nucleus, there is an emission of a particle which is called final particle. Final particle. But as I said, in the case of nuclear reaction, along with the nucleus which is formed, there are the particles which is formed. Sometimes it can be more than one particle also. But this is the general equation that can be written for writing what? Nuclear reaction. But this same reaction equation can be written in short form also. Short form, you can write this way also, like X, comma, bracket A, comma, B leads to what? Y. That means the nucleus can be written outside the bracket, where particles involved in the reaction can be written inside the bracket. So X plus A combined to form Y plus what? B. But that can be written in short form as X, bracket A, comma, B, bracket Y. So this is the way also we can represent the nuclear reaction. That's why the particle involved in the reaction, you can see is written in the bracket, where the final initial and the final particle are written outside the bracket. So this is the way we can write the nuclear reaction. Now the question arises out here is, what type of particle can participate and can have strong interaction with the nuclei? Now there are the certain particles which can have in nuclear reaction with the nucleus. Okay, and the particles are, just to inform you that what are the particles that are involved in the nuclear reaction. The particles are basically like alpha particle. You know alpha particle, you have learned. And alpha particle are nothing but the positive charge particle, which is called helium nucleus. Win is helium nucleus. Similarly, particles like proton can also have a nuclear reaction. Okay, proton can also have nuclear reaction, and we mark by letter H11 or P, because proton is equals to the hydrogen atom. Okay. Similarly, particles involved in the nuclear reaction can be what? Deuterium. Okay, deuterium is given by H12. Okay, deuterium, or we can also mark by symbol D also. Neutron can also have, neutron is also a particle which can involve in a nuclear reaction, and this can be marked by letter N. Similarly, the particles like gamma ray photon. Okay, gamma ray photon are the light particles. Okay, gamma ray photon, which are the light particles, can also have nuclear reaction. Are the particle which involved in the nuclear reaction. Okay, so these are the common example of particles which may involve in the nuclear reaction. Now the next part that we need to understand is, when the nuclear reaction occurs, then this nuclear reaction are basically attended by the liberation or absorption of energy. Means whenever nuclear reaction occurs, as I said, there is either the liberation of energy or there is absorption of energy. That means this nuclear reaction is always happens, okay, either by the liberation of energy or by the what? Absorption of energy. Okay, and this energy which involved in the nuclear reaction is also called reaction energy, or also called as disintegration energy. Also called what energy? Disintegration energy. So the energy involved in the nuclear reaction is also called reaction energy, also called disintegration energy. Now the next point that you need to keep in mind, children, under nuclear reaction is, in every nuclear reaction, the charge, the total number of nucleons, means proton and neutrons, which I call mass number, and the total mass plus the energy also remain conserved. So energy is conserved in nuclear reaction, mass is also conserved in nuclear reaction, the charge also remain conserved in nuclear reaction, and the number of nucleons, which is called proton and neutrons, also remain constant or conserved in the nuclear reaction. So nuclear reaction is one of the good example which can make you to understand the conservation of energy, conservation of mass, conservation of charge and all. Okay, so for this we can now write some of the nuclear reaction, common nuclear reaction that can be observed, okay, and important for your examination also. Now let's start with number 1, some of the nuclear reaction. There are many nuclear reaction can observe, but we will discuss only the important nuclear reactions. So number 1 nuclear reaction that can be observed is like aluminum. One of the nucleus of element like aluminum, whose mass number is how much? Atomic number is 13 and mass number is 27. See, atomic number means number of proton which remain inside the nucleus, and mass number is also the total of proton and neutrons present inside the nucleus. So the nucleus of aluminum can have strong interaction with one of the particle, and I write that particle is H12. So one of the particle H12 means this is deuterium. You know, deuterium is one of the isotopes of hydrogen as a particle which can have interaction with this nucleus. So when it have interaction with nucleus, then it leads to the formation of new nucleus, and the new nucleus is called final nucleus, and the final nucleus which is formed out here is the nucleus of magnesium, and magnesium with atomic number 12 and mass number 25, and along with this the new particle which will liberated will be helium nucleus. So the alpha particle, so you know helium nucleus is what particle? Alpha particle. So remember this, helium nucleus is what particle? Alpha particle. And this alpha particle can be evolved by the strong interaction of aluminum, okay, nucleus which is 13 and 27 with one of the isotopes of hydrogen, that is called deuterium. So when they have strong interaction, the alpha particle, that is called new nucleus, is liberated. Along with that, the new element, nuclear nucleus, is formed, that is called magnesium. So this is one of the nuclear reaction. Similarly, I go to number 2. In number 2, let me just take one of the element called boron. Boron with mass atomic number 5 and mass number 11. So when boron have a strong interaction with one of the particle of a proton, H11 is also called proton. Okay, positive charge particle, and that is equals to the hydrogen atom with 1, 1. So when they have a strong interaction, we get a new nucleus. The new nucleus which is formed is called beryllium nucleus with atomic number 4 and mass number 8. And what will also form? The new particle which is formed in this reaction is called He24, the alpha particles. This is also called what? Alpha particle. But when we write nuclear reaction, children, remember this, the total number of neutrons, protons, number of neutrons remains same. Okay, so 5 plus 1 is 6, 4 plus 1, 2 is 6, 11 plus 1 is 12, 8 plus 4 is 12. Okay, so it is balanced. Similarly, number 3, if I go to next number, nuclear reaction, let me just take another example. Like if I take the same boron, if I, like with 5 and 11, if has interaction with the alpha particle, now this time alpha particle, He24, a positive charge particle, then we get a new nucleus that is called neutron and nitrogen. Nitrogen as a gas element with atomic number 7 and mass number 14. Along with that, the new particle which is formed, that is called neutron. This is called neutron. So the liberation of neutron can be done this way also. So we can generate neutron as a particle, a neutral particle, by the bombardment of this nucleus, boron nucleus, with the alpha particle. Similarly, we can go to next nuclear reaction. Like let me take one of the nucleus, aluminum again, with atomic number 13 and 27. Now if I bombard with one of the uncharged particle, that is neutron. Yes, we can bombard with this way also, means they have interaction. When they have a strong interaction, we get the new element which is nucleus or element is formed, that is magnesium with atomic number 12 and mass number 27. Okay, so along with this, the proton will form H11. So this is a new initial particle, this is a final particle. Initial nucleus, final nucleus. So with this neutron bombarded with aluminum, we can get proton. We can obtain what? Proton as a particle, new particles. Similarly, let me go to another example for this. Okay, say example, let me take carbon C612, one of the stable isotopes of carbon. If I bombard with one of the isotopes of hydrogen, that is called deuterium. Deuterium. Okay, now you get a new nucleus and new isotopes of carbon, that is C613. C613. Along with that, we get one of the particle called proton. One of the particle called proton. Okay, so bombarding with deuterium, we get one of the isotopes of hydrogen, that is called protium, and this is also called the particle equivalent to which particle? Positive charge particle of proton, along with the formation of new nucleus. Okay, similarly, I go to next one. If I bombard one of the alpha particle, one of isotopes of hydrogen, with gamma ray photons. Yes, we can do this way also, gamma ray photons. Okay, then it leads to the discovery of one of the isotopes of hydrogen, that is called protium, plus what will also form? The neutron will also obtained, because 1 plus 1 is 2, 1 plus 0 means 1. Okay, that means in nuclear reaction, gamma ray photon can also involve to have in nuclear reaction with the nucleus to form the new particles. With what particle? New particles. Similarly, we have number 7. Let me just go next one. If I take carbon C612, if it bombard with one of the neutral particle called neutron, we get a new nucleus, and that is boron. Okay, boron with mass atomic number 5 and mass number 11, plus one of the isotopes of hydrogen as a particle we obtain, that is called H12. So deuterium can be obtained by bombarding carbon, one of the stable isotope carbon, with neutron. Okay, so in nuclear reactions, you can see in every nuclear reaction, particle bombarding with nucleus form new nucleus along with the new particle. But along with this, remember this part, the energy will be liberated and energy will also be absorbed. But the total energy, mass, okay, nucleus, everything remains what? Same. Okay. Now let me just go back to next, reaction also. Okay, let me go to next one. Okay, in the next part, let me just do with lithium. Let me take lithium 3 and 7. If it bombard with one of the alpha particle Hg24, then we get even out here as boron, one of the isotopes of boron. So children, boron also has isotopes, boron 5 and 10, along with the formation of a new particle, uncharged particle called neutron. Now let me do the last two reactions that leads to the discovery of new particles other than this neutron, proton, okay, alpha particle and all. Okay, and one of the reaction is carbon C614, one of the unstable isotopes of carbon, can have a disintegration. Okay, that can have a disintegration to produce beta particles. Beta particle is given by beta with -1 and 0, and this beta particle is also called the fast moving electrons. Okay, along with that, the neutron with mass atomic number 7 and 14 will form. Along with this, there is a particle which is obtained, which is marked with a new bar, and this particle is called anti-neutrino. So there is a new particle which can be obtained in nature when carbon C614 undergoes a disintegration reaction. Okay, with the liberation of neutrons and nitrogen 7 and 14 and beta particle, and this particle is called anti-neutrino. Now anti-neutrino is a particle, and it is actually a what particle? Anti-particle. Let me just tell you, it is an anti-particle, okay, of a particle called neutrino. So let me just write down, there is a new particle, unstable particle can obtain in nature, that is called neutrino. Actually neutrino is a subatomic particle. See, this is a subatomic particle, subatomic particle. So neutrino is a subatomic particle, and this is similar to an electron but has no electrical charge. The subatomic particle which is similar to electron but has no electrical charge is called neutrino. Okay, and a very small mass. It has a mass but a very negligible mass. Okay, which might even but 0. That means the mass of this neutrino even what? 0. Okay, and they have a very little interaction. That means this neutrino can have a very little interaction with the what? Other particles or other nucleus. Okay, and it is actually electrically neutral. It is electrically neutral, and such particle is called neutrino. So neutrino is one of the unstable particle. So let me tell you children, unstable means it cannot remain in the atom, nucleus of an atom, inside the atom. That means this is the particle which cannot reside. It's unstable particle. Once it evolved, it will simply collapse also. Okay, and such particle, subatomic particle, which is similar to what? Electron, having no charge, electrical charge, is called anti-neutrino. Neutrino. But there is an antiparticle of neutrino, and that antiparticle of neutron is called anti-neutrino. And this particle also have no charge. It has no charge also. Okay, but as I said, it is similar and having same mass. The mass is same, but opposite charge of the neutrino. That means, okay, this particle is called anti-neutrino. So this type of particle can even involve when the reaction involved like this way. Actually, this reaction which I have written is the reaction of the emission of beta ray. Yes, this is one of the beta ray which involved from the nucleus of an element, radioactive elements, under the process called radioactivity. Okay. Similarly, carbon C611. Okay, one of the element of carbon. Okay, can have undergoes a disintegration reaction with the production of boron 5 and 11 with a particle which is proton, which is also the antiparticle of electron, and this is called positron. So positron is plus E1 and 0, and along with that there is a particle which is obtained, and that is called neutrino. So children, look at this two reaction. In these two reaction, if you see, other than this alpha particle, electron, proton, okay, deuterium, they are the particle which has been evolved, okay, elaborated as a new particle, but these are the unstable particle, and these particle are like, this is called, positron. The positron is one of the antiparticle of electron, antiparticle of what? Electron, having same charge and mass of electron. Okay. Now neutrino, as I said, is a particle. Okay, is also particle similar to the electron, but have no electrical charge. This is neutrino. Similarly, you saw that there is a particle which is also obtained, antiparticle of neutrino, that is called antineutrino. So these are the unstable particles which can even liberated when there is a strong nuclear reaction takes place or disintegration reaction takes place. Okay, so nuclear reaction leads to the formation of new particles also. As the reaction takes place is very strong, okay, with the liberation of strong energy, large amount of energy, or there is a absorption of energy, but with the liberation of new particles and all. And these particles are basically what particle? Unstable particles. So with this video or your chapter, nuclear structure is completed. Now we will be starting the new chapter on the unit number 8, mass energy equivalence.